PSB7 does pick up real ghosts. How? Just the same way as it's scanning, as the PSB7 is scanning. It's going, say this is AM station 110, and this is station AM station 112. As it goes, right, is it scanning station to station?
The guy here, which is the, the ball magnet, and now we have reaction, right? We have reaction, right? So I mean, like, because the field is really strong now. Now, the field is going right through the meter. Now, as you see, now I activate it as resonance, because now when I'm talking, you will see the needle go up, 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 up. It must be a certain, is my low tone.
They're alive, hangs around as long as there's energy there.
They modulate that white noise into words.
In between is a milliamp spark gap. In between is created a broadband wave that opens up a communication device. So the ghosts have milliseconds to say what they can, because it's an electromagnetic field caused through the picks up electromagnetic field, which is the human voice, is a sound wave, and the scanning. Okay, I'm not explaining it all correctly, but the scanning picks up the scanning picks up the ghost voices that are speaking through it. Voices accidentally come through the waves, so it opens up a new broadband, AM or FM, depending on what you're scanning on, and the ghosts are speaking. So in between that, in milliseconds, that's why it's called. If you look here, turn on the PSB7. There's MS. Look, 400 MS, milliseconds, right there. Milliseconds. MS, milliseconds. You can switch how fast it sweeps, right? It's always MS, milliseconds. So in between those milliseconds, ghosts are speaking.
So as I'm speaking, the needle is moving. Now, I won't speak anymore. The needle's not moving anymore. Okay? Now, it goes right through. Okay? And I'm just going to scratch on the side of the box. Okay? I didn't build this instrument. The scientific world built the goddamn thing. Okay? But this thing here is analog. It doesn't fail. That's like, it's just like a brick. It's nothing to fail in there. So if it would be picking up any type of electromagnetic field will actually move.
Talking about the
Look
kids.
at, I know.
Look at, hold on.
Do you have
What happened?
turn it this way? I just turned it on.
Why is it doing that? That's never done that before. And this is right where we just heard that laugh. Yeah.
EMF readers are used to measure electromagnetic energy, which ghosts are said to be made up of. Aaron's was spiking off the charts. We pulled out a second EMF reader to verify whether or not the first was giving us a faulty.
Do you feel hot when you walk in the sun for a few minutes? This is because the sunlight carries light and heat energy, and see what happens. Hold the leaf such that the sunlight directly falls on it. Now hold the magnifying lens above the leaf. You will see that there is a bright spot on the leaf, which is the beam of the sunlight focused by the lens. Observe what happens to the leaf. The leaf starts burning. Why did the leaf catch fire? The lens converged the sun rays onto a small area of the leaf. The heat energy carried by the rays are now focused on this area of the leaf. As this area receives more intense heat, its temperature gradually rises.
And just walk underneath the power line and just let the other wire just dangle. It doesn't have to be nothing attached to it. And you will see you're picking up volts. Well, you didn't see any volt coming out from that piece of copper to the power line, because there's no volt coming out. It's all in the volume of resonance. What you're seeing is the amount of volt you got is the amount of volume of resonance that little piece of wire picked up.
Reading.
Two actual tri-film meters doing the same thing right now.
And it's fluctuating. The left one's
What
fluctuating.
in the hell, dude? And there is no electricity in here, Todd, is there?
There is no electricity. None whatsoever.
With no source of electricity to cause the energy spikes we were measuring, we had to ask ourselves if our EMF readers were indicating that the possible spirit that had been taunting us earlier by laughing was now right next to us.
And you don't have to move fast. I mean, like if it would move in, I mean, a micro of an inch per second, I would be able to read it.
Our film centers on Aaron and Abby, who spent many years together researching and getting very into the science of ghosts.
Shocked as well. White sage to magically get rid of the ghosts? Really? That's not science. Unless you take the white sage and transmit it to a frequency, then it would hit them. This makes them. This tickles the ghosts. Yeah, how you doing? This tickles the ghosts.
Hi.
Tickles them and smells nice. Decreases activity. Well, ghosts can smell when you burn white sage, so they might calm them down.
My name is Dr. James Maxwell, and I'm a senior postdoctoral associate at MIT's Laboratory for Nuclear Science. The first thing that they asked me was, how would a proton pack work with as few huge leaps of miraculous science as possible?
I call that, this is the voodoo machine. He does all kinds of trick, you know. So I mean, to the point you see, you can take picture with a proper camera of other entity around you when you run this machine.
I got you! It's chipping time now, Ghost! And this is what you get for sitting on me!
Miss me! Thanks, Patty.
And I believe me, I took picture of them, so I have picture of them. And I showed up to people. Everybody comes in, doesn't believe me. I pull my laptop up and I show them the picture, and they go, holy shit. Right, because they're not pretty looking. So here we go. So if you want to scare the crap out of yourself, build yourself a machine and have a party with some identity. You know, they're not that, they look terrible, but they don't do anything to you because we're not working in the same resonance. They're all around us. I can detect them now. I can read it because they leak of millivolts when they walk by you, when they pass by you. They have, you can feel, you know, for a split second the millivolt will go up and the sensor and drop down just as someone walked by you. And some of the big, they have more millivolt. Some that are smaller, they have smaller millivolt, because volt is volume. So whatever size beings walking around, you can pick them up in millivolt. And that's why, you know, Ghostbuster machine for finding ghosts and stuff like this, you know, they carry, all you have to do is having something that can, you know, read millivolt or nanovolt, and you will be able to pick up anything passed by you.
Of course, I remember from the first Ghostbusters that they used a cyclotron. In the cyclotron, you have two electrodes, and your particle starts in the middle and spirals outward, gaining speed. So I think, well, this is now. We're going to use a synchrotron, which are no longer spiral, but you actually can vary the magnetic field in a ring.
I mean, like, you know, why I take picture of stuff around me. I know what the camera would just an app, a thermal imaging app, and a smartphone. And when I was running the machine in my other place, we took picture of an entity around us, and I got probably about 50 people who actually saw the picture, and it just blew their mind away. You know, I mean, because it's very simple. I'm creating a three-dimensional of electromagnetic field.
Well, in order to have a synchrotron, it probably has to be superconducting, because you're going to need very high magnetic fields It's going to have to be compact, so you need a superconducting magnet, which means you probably have to have some cryogens, so you need a source of liquid helium to keep my magnets cold. Let's put a cryo cooler in there to get some active cooling. Particle accelerators are real, superconducting magnets are real. The big leaps of faith are actually doing it in the space that's allowed. It's been really fun to look at the cool ideas the writers come up with and try to say, okay, that's a cool idea. How about if you did this and then it would sound a little better? One of my colleagues at MIT, she's been working with them rather closely to make sure that the blackboards and all the papers that you see strewn around the laboratory are accurate. They did such a spectacular job.
Really do not work or do not show the way the world of science say it is. You know, all you gotta do is go buy yourself a tri-film. You know, they're like $200 and some. Go buy yourself one of those and then do your own tests. I mean, you know, you don't have to, you know, to be, you know, anything. Well, there's just a coil, just an aluminum coil. So if I'm producing enough of those friction, suddenly I'm producing a hertz, and then suddenly volt shows up.
We'll use the white noise to try and communicate with us. So we'll give that a go now, yeah? So. For God's sake. Battery's gone.
Seriously?
Yeah. This is a bit of a joke, this, isn't it?
Oh, not you guys again! Say hello to my little... What the hell?
Look, that's it there. It's just gone off, yeah?
Yeah.
Everything's getting drained.
Ow! You see that? I touched this and see that? The ion motor is here. Explain, ouch. Explain how this electricity is coming through the air and electrifying this metal when there's no wires on it. Look at that. The ions are coming from here. Look at that. See that? Ah, shit. See that shit? That's how ghosts can knock out your equipment. Can you hear the static on my phone? Actually slowing down the ion motor. Hear it? You hear that? When ghosts come near your little ghost detectors, you pick it up. I said, when ghosts come near your ghost detectors, you pick it up. Look at that. See that? You hear that? Now, ghosts are ionized and other frequencies and signals that you have no idea about, that you should learn. These devices really do pick up ghosts, all of them, combined or whatever. But stop faking your ghost sessions. It's really annoying. Right? So a spark gap, the P-SB7 is scanning. You hear that? Look, I'm turning up the volume. You hear the ions coming through the P-SB7? Oh, my batteries are starting to get drained. What's happening? Ions. Knocking out the batteries. That's why your ghost equipment gets knocked out. Like, what the heck is going on? Well, that means there's ionization around. Some entity is fully charged. Yeah, listen to that. Alright. Now a spark gap is what's happening. In between the scans, there's a spark gap. As the scan jumps from one side, as the scan jumps from one station to the other, it creates a spark gap.
You know, I find EMF, RF, which now we know is bullshit, is literally a resonance. You know, that's why you have a release of an electric motor.
It's a good sign that we're in the pathway of a spirit passing through our body.
Yeah, it's got to be a good 90-something degrees in here.
See the sweat dripping? Also,